Good morning everyone. Today we are going to see Operating System Unit 3, Session 14. In the previous session we have studied various methods of handling deadlocks. In today's session we are going to study another last method of handling deadlock, that is deadlock avoidance. So in this method the operating system is trying to avoid the deadlocks which is going to occur. So first of all, the operating system is going to detect the deadlock. If there are chances of occurring the deadlock, then operating system is going to try to avoid the deadlock using the algorithm, and that algorithm we call it as Banker's algorithm. So using this algorithm, it is going to try to avoid the deadlock which is going to occur. So for operating system to detect the deadlock, it must have the knowledge about the resource allocation knowledge, which process is requesting which resource, and currently the resource is with which process, and which are the new request or the new demand of the processes for which type of resource, and is it possible to allocate the resources to the processes. So if we allocate the resources to the processes, does your system still enters in the deadlock or it comes out of the deadlock? These all will be handled by the operating system in the deadlock avoidance. So try to avoid deadlocks by making use prior knowledge about the usage of resources by processes. So as I told you, the operating system should have the knowledge about the processes and resources, like resources available and resources allocated, for which processes resources are allocated, future requests, which are the new demand, new request, and future releases by processes. And after using the resources, how much resources will be released or freed by the processes. So this all prior knowledge the operating system must have to detect the deadlock and to avoid the deadlocks. Most deadlock avoidance algorithms need every process to tell in advance the maximum number of resources of each type that it may need. So avoidance algorithm can be used to avoid the deadlocks to occur in the operating system. So for that it needs the knowledge about the allocation of the resources. Based on this information, we may decide if a process should wait for a resource or not, and thus avoid chances for circular wait. So there are three types of states which may occur in the system: safe state, unsafe state, and deadlock state. So safe state is that you can allocate the resources to the processes and there is a proper and smooth flow of execution. So all processes can able to use whichever resources they are requested, they can able to use it. So that means there are no chances of occurring the deadlock in the system. So that we call it as safe state, when all resources and processes are able to use the resources and you can allocate the resources to the processes, then it is a safe state. Unsafe state is that suppose one of the processes requests some resources and that resource is already held by other process and it is busy, okay, and even that process is holding another resource. That means they are waiting for each other resources. So this creates the circular form and there are chances of occurring the deadlock in the system. Then the deadlock occurs only in the unsafe state. It does not occur in the safe state. So before allocating the resources or before executing the processes, the operating system has to take care about safe state and unsafe state. So operating system has to stay away from the unsafe state because there are chances of occurring the deadlock. Even if the deadlock occurs, the operating system should find out the ways or solutions to come out of that deadlock. That means one of the processes has to release the resource. Then operating system can avoid the deadlocks. So in advance, the operating system comes to know that which is the safe state and unsafe state, and it can change the flow of execution to avoid that unsafe state. Definition of safe state: when a process requests an available resource, system must decide if immediate allocation leaves the system in a safe state. So if you give the resource to that particular process who is requesting, still your system remains in a safe state or unsafe state, that will be decided. A safe sequence of processes and allocation of resources ensures a safe state. If a system is already in a safe state, we can try to stay away from an unsafe state and avoid deadlock. Deadlocks cannot be avoided in an unsafe state. So this is one diagram which indicates this is a flow of process 1 and column wise it is a flow of process 2, and both processes are going to use the resources, and this flow indicates process 1, and here column wise this flow indicates process 2 execution, this flow indicates process 1 execution and process 2 execution. So there are resource 1 which can be used by both process 1 and process 2. Then this is the point where both processes request for resource R1. So this has to be handled carefully by the operating system whenever allocating the resource for process 1 and process 2. There is another resource, and even this resource is used by both process 1 and process 2. So this is the point where both process 1 and process 2 are requesting for resource R2. So these both points must be handled carefully by the operating system so that the system should not enter into the deadlock. So if you combine this is the resource 1 and this is the resource 2, and this is the point where both processes are requesting for resource 1 and resource 2. So there are the chances at this point, there are the chances of occurring the deadlock, means system is going to go in the unsafe state because both processes are requesting for resource 1 and resource 2. So the operating system must try to avoid the system to enter into the unsafe state. Once the system enters into the unsafe state, there are chances of occurring the deadlock. So the operating system's responsibility is to avoid the deadlock. So the solution for this is that operating system can try to avoid the deadlock by changing the flow of execution. You can see in this diagram. So this is the flow where there are chances of occurring the deadlock. This is the allocation of resources for process 1 and 2 where there are chances of occurring the deadlock. So if the operating system makes the allocation in this way, there are chances of occurring the deadlock. So to come out of this deadlock, to avoid the deadlock, the operating system can change the flow of execution. So it can change the way of allocating the resources to the processes in different way. So it has changed the way of execution or allocation of resources to processes so that it can avoid the deadlock. So like this way, the operating system can try to avoid the deadlock and come out of that unsafe state. It can change the flow of allocation of resources to the processes. Next is Banker's algorithm. This Banker's algorithm is very important from the exam point of view. So the question or the problem will be asked on this Banker's algorithm is for 10 to 15 marks. So it is very important from exam point of view. So Banker's algorithm is a resource allocation and deadlock avoidance algorithm. So using this Banker's algorithm, we can avoid the deadlocks. That means we can change the flow of execution of the processes and to allocate the resources to the processes. So for this algorithm, which processes have requested which resources and which resources are allocated to which process. This information this algorithm needs. It also checks for safe state. If after granting request, system still remains in the safe state, or it allows the request, and if there is no safe state, it don't allow the request made by the process. So it is going to decide whether to allocate the resources to a particular process or no. By allocation, if the system is going to remain in a safe state, then the resources will be allocated to that particular process. Otherwise, the resource will be not allocated to that particular process. This will be decided by this algorithm. So for this algorithm, it needs max need of resources by each process. Maximum need means how much resources each process needs, maximum resources, and it also needs the knowledge about currently allocated resources by each process, and it also needs maximum free available resources in the system. So request will only be granted under following conditions. So whenever the request, that is resources, are allocated to processes is under following condition. That is, if request made by process is less than or equal to max need to that process. That means whichever the new request, new demand has come for a particular resource. For example, already a printer is used by another process, and if there is another process comes and it is requesting for printer. So if it is demanding the printer for 2 to 3 times and only, but the operating system, that this algorithm should see that whichever the request is coming should be less than the maximum. Okay, so that it can be allocated. If it is more than maximum, then it cannot be allocated. If request made by process is less than equal to free available resource in the system. And also, so there is another condition where the operating system can grant the request, that is resource, to the process. That is, if the available free resources, now suppose there are 10 resources and out of 10, 5 are already allocated and remaining only 5 are there. So from the 5, if the new request is less than 5, then we can allocate the resources to that particular process. If that particular process's request is more than 5, then we cannot allocate. So it must be less than the available free resources, then only the resources can be allocated to that process. So again, this Banker's algorithm is divided into 2 types, that is safety algorithm and resource request algorithm. So this safety algorithm is used to check out after the allocation of resources whether your system still remains in a safe state or no. And we use this resource request algorithm. Now suppose the same process is request for again new demand. So can the operating system fulfill the new request of the processes? If yes, then it is going to check out still the system remains in a safe state or not. Then only the new request of the same processes will be fulfilled, otherwise no. If the new state is unsafe, the resources are not allocated and the data structures are restored to their previous state. In this case, the processes must wait for the resource. So to fulfill the demand of same processes of new request, then currently if it is not able to allocate the resources because the system may go in an unsafe state, then such processes will be made to wait for until some of the processes releases the resources. Then the allocation will be made. So as I told you, the operating system must have the knowledge about this, that is, which you have studied. Okay, you can see here. If you want to solve the problems on the Banker's algorithm or how the Banker's algorithm works. So Banker's algorithm need these all things, that is the number of processes. N denotes number of processes. M is nothing but number of resource types, and available is nothing but total how many resources are available. That is, you can check out these are available resources, means total after allocation how many are available, and then maximum, max. So max is nothing but total how much maximum resources are available, and next is allocation. So that is nothing but this allocation matrix. So this knowledge the operating system must have, and then the need. So this need is find out, see, max minus allocation. So after max minus allocation, so these are the, like suppose the 10 resources are available. So out of 10 resources, 5 are allocated. So how many, what is the need? So that particular process needs 5 again resources. So like this way the need will be find out, that is max minus allocation. Okay. So max minus allocation, even this you can say a new request where the various algorithm must be used. So the operating system uses Banker's algorithm and it must have the knowledge about these all maximum available and after allocation how many are remaining current allocation and new request and the need matrix. So this is the safety algorithm. So this is the flow, how the system works, how the operating system handles the means it is going to check whether the system is in a safe state or not using this algorithm. Next algorithm is resource request algorithm. So this is the algorithm where the operating system checks whether the allocation of a new request or new resource to the processes still your system remains in a safe state or no. This algorithm will be used. Now let us solve one problem. So in the exam they'll give the problem like this way. Consider a system with 5 processes and there are 3 resources available, A, B and C. Resource type A has 10 instances and B resources has 5 instances and C resources has 7 instances. Now you can see here the number of processes, allocation, max and available. So this is the number of resources allocated for process P0, P1, P2, P3 and P4. So out of this maximum, these are already allocated and total remaining resources are these. There are 3 resources available of A, 3 resources available of B and 2 resources available of C. Now first of all, you need to find out the first question which will be asked is what will be the content of the need matrix. So always first step is to find out the need matrix, that is max minus allocation, and you will get here need matrix. So we already got here max minus allocation, that is 7, 7 minus 0, that is 7, 5 minus 1 and 3 minus 0. Similarly next also 3 minus 2 and 2 minus 0 and 2 minus 2. So after subtracting this you will get here need matrix. So these values you will get. So this is the new request of the processes they need here. So P0 needs 7 resources of A, it needs 4 resources of B and it needs 3 resources of C. So now you need to find out, can you fulfill the demand of P0, P1, P2, P3, P4, and after fulfilling the demand of each processes, still the system remains in a safe state or it goes in an unsafe state. So operating system should try to avoid that system should enter in an unsafe state. So that's why this algorithm is used. Second question asked is the system in safe state? If yes, then what is the safe sequence? So for this, to find out whether a system still remains in a safe state after the new allocation of resources to the processes. So when you try to fulfill the new demand of the processes, can your system still remains in a safe state? So for this, M indicates number of resources available 3 and N indicates number of processes available. Work is equal to available. This is nothing but total available resources. You can check out in that matrix, total available resources are 332. You can check here, these are the available resources 332. And at the beginning, all processes will be initialized to false. So this is needed to check out that which is the safe sequence. This is needed to check out which processes can be executed first, which process demand can be executed, means fulfilled first. So at beginning all will be initialized to false. So whichever process demand will be fulfilled, that process will be made here true. So first let us start with the process P0, that is I is equal to 0, that means process P0. So what is the need of the process P0? Check out here need matrix. So the need of process P0 is 7, 4, 3. You can see here, this is the need of process P0, 7, 4, 3. So does the enough resources are available? You check out. See, process P0 needs 7 resources. It needs 7 resources, but how many are available? Only 3 are available. Okay, so you cannot fulfill the demand of process P0 because it needs 7 A resources and only 3 A resources are available. Similarly, you can also check another resource. So at the beginning only you understood that you cannot fulfill the request of process P0. So this process will be kept in a pending list. Means you cannot fulfill the demand of P0. So now the operating system checks the process P1 request. So what is the need of process P1? 1 to 2. You can check the need matrix here. So always you need to check the need matrix here. So process P1 needs one resource of A. And how many are available? 3. Yes, you can fulfill the demand of process A. Check out the another resource. Process P1 needs 2 resources of B. And there are 3 available. Yes, you can fulfill the demand of P1 it is. And next you can see process 1 needs 2 resources of C. And 2 are available. Yes, currently you can fulfill the demand of process 1 because all resources whichever it needs of resource A, B and C all are available here. And you can fulfill the demand of process P1. So you can keep here process P1 in a safe sequence. So process P1 process request can be fulfilled and process P1 is the first one of which you can fulfill the demand. Then next step is this is the available total and this is the allocation. So currently how much the process P1 was allocated, check out in this matrix. See, P1 was allocated, earlier it was allocated 200. Now after taking the new request, it is going to release this previous allocation. Before taking the new request, it is going to release this previous allocation so that it can be given to other resources, other processes. So it is going to release the previous allocation and it will get added to the available. See, 3 plus 2 it is 5 and 3 plus 0 it is again 3 and 2 plus 2 it is again 2. So now the available will increase because the P1 has released the previous allocation. Now available has increased here and we have made here process P1 to true, means it is the first process whose demand can be fulfilled. Now let us try the next process, that is I is equal to 2. So it needs 600. You can check out the need matrix. It needs here 600. So how many resources are available? See, now you need to now check the new resource available. Okay, the new resource which is available here is 5. You can see here it is a 5 and it needs 6. So there are not enough resources available because it is demanding 6 resources of A and only 5 are available. So you cannot fulfill the demand of process P2. So keep P2 in a pending list. Now you go for the next process, that is P3. So this is the need of P3 and P3 needs 011. So check out here, new resource you check out. So process P3 needs 0 resources of A. Okay, that we are not going to consider. So it needs 1 resources of B and 1 resources of C. And there are already available here. 3 resources of B and 3 resources of C are already available here. Yes, you can fulfill the demand of process P3. So keep process P3 in a safe sequence. So next process which demand can be fulfilled is P3. Then whatever the previous allocation was there, it is going to release it. You can check here the previous allocation of process P3. What was the previous allocation? Check the allocation here. Is 211. So this will be released now before taking the new resources. So you can check here, it is going to release these resources and it will get added into the new resources. That means it will get added into the previous resources and you will get here now new resources. So after adding this all, we will get new resource and you are going to make P3 as a true because P3 is the now next process to be fulfilled. Okay, now let us check the process I is equal to 4. That means process P4. So process P4 needs 431. Can you fulfill the demand of process P4? Check the new resources available. Yes, see, process P4 needs 4 resources of A and there are available how much? 7. Yes, you can fulfill the demand of process P4. 3 resources it needs. How many are available? 4. Yes, you can fulfill. It needs 1 resource of C. Yes, all are available. So you can fulfill the demand of process P4. So keep process P4 in the safe sequence now. And whatever it has allocated earlier, it is going to release now. And it will get added into the previous resource available. So now the resource will again increase. And I want to make here P4 true. So now whichever the processes were in the pending list, now once more I want to check here from the beginning, whichever processes you were not able to fulfill the demand. Now you check once more. Can you able to fulfill the demand of those processes who were in the pending list, who were waiting? So check I is equal to 0 and its demand was 743. So can you now fulfill the demand of process P0? Check out. Yes, you can fulfill as it needs 7 resources of A and all 7 resources are available here. Check out of another resource B. Yes, 4 resources are available. Check out of another resource C. Yes, 3 resources are available. Okay. So you can fulfill, now you can fulfill the demand of process P0. So keep process P0 in a safe sequence and whatever it has allocated, release it and now it will get added into the new work. So now new available will increase here. So whichever process are in a safe sequence, before taking a new resource, previous allocation they have to release this, and this is what we have shown in this step. Check out another pending process which was in a waiting state. Check out here. So it was needed 6 resources of A. Can you fulfill? Yes. There are 7. You can fulfill the demand. So even you keep now process P2 in a safe sequence and whatever the earlier it was allocated, it is going to release now and it is going to get added into the available work. So here after adding, the available work will increase. So this is the safe sequence you have got. So if the operating system goes in this sequence, first P1 has to be fulfilled, has to be executed, and then P3 will be given the resources and then P4 will be given the resources. If the operating system follows this sequence, then the system remains in a safe state. So yes, you can currently allocate the new request to all the processes and still your system remains in a safe state. Now suppose at the beginning only, if you try to fulfill the demand of process I0 only, that is process P0, then here only see there are not enough resources available. See here. And your process gets stuck here and none of the processes demand cannot be fulfilled here because there are no resources available. So the bankers, that is safety algorithm, is used to avoid that problem. So next question will be asked, that is what will happen if process P1 requests one additional instance of resource type A and 2 instances of resource type C. So now already the process P1, this is only about process P1. Already the process P1 has requested some request. You can see in the need matrix, check the need matrix here. Already the process is waiting for these resources 1, 2, 2. And upon in that it has requested some additional resources, that is 1, 0 and 2. So can the operating system fulfill the demand of this? Okay, when the operating system tries to fulfill the demand of this process P1, can the operating system still remains in a safe state? That can be found out using the resource request algorithm. See. So these are the steps which is carried out here. So first step is you need to check out here. You need to compare here request with need. So this was the need of P1 which it was waiting, and then upon that it is requesting new additional resources. So check out. Okay, here condition is that the request must be less than need. So check out, see, it is demanding 1 and there 1 is available here. It is demanding 0 and here 2 are available. It is demanding 2 and yes, 2 is available. That means less than equal to it is. So request must be less than equal to need. So if this condition is true, then only you proceed to the next step. Otherwise, if this condition is false, you need to stop this algorithm here. Now here condition is true, so we are going to move to the next step. Now the request has to be again compared with the available. Okay, so this was the available. So even this request must be less than the available. Yes, even this is true. You can see here it is requesting 1 and there are available 3. It is requesting 2 and there are available 2. Yes, you can fulfill the demand because it is less than. Now move to the third step. In third step you need to calculate this. So in the third step you are going to get new available, new allocation and new need of a process P0 only, P1 only, okay, because P1 is requesting additional. So the again value changes of the P1 because we are again subtracting this. So what was the available here? 3, 3, 2. And what is the request? 1, 0, 2. So you need to subtract this, then you will get here new available. What available you will get here? This available you will get 2, 3, 0. So after subtracting you will get here value 2, 3, 0, which is your new available. Then next, allocation plus request. So what was the earlier allocation? You need to check out here. What was the earlier allocation of process P1? See, 200. It is 200. So you are going to add this 200 plus new request 102. Then you will get here new allocation. What is the new allocation now? 30. This is the new allocation. So 302 after adding. Now need minus request. What was the need of P1? You can check out here. P1 need was 122. You can see. So it is 122 minus request. What is the request? 102. So 020. So you can check out here. This is the new need. So like this way we have got the changed values of the process P1. Now check out after trying to fulfill the demand of process P1, still your system remains in a safe state. Now again you need to follow the same steps here. This time the available will be changed here. Okay. Now the available is 230. Now again you are going to start with the process P0 only, so that your system should not go into the deadlock. So you need to again decide here which is the safe sequence. The operating system decides here. So this was the need which is cannot fulfilled. So P0 will be in the waiting list. Then check out the process P1. So this is the new need as you can fulfill the demand of process P1 because there are enough available here. So P1 will be put in a safe sequence here. Then earlier allocation it is going to release it and it will get added into the resource. And even this will made through. Now check for process P2. This was the need. So can you allocate? No, it is requesting 6 resources, but there are only 5. So keep P2 in a pending. So same steps you are going to repeat again. And whichever the processes was in a pending, you check here once more. After checking out all the processes, once more the processes which were waiting, you check out can you fulfill the demand of those processes. Okay. So like this way you are going to find out safe sequence. If you get the safe sequence, then yes, you can allocate the resources, means additional resources to process P1. So this is how the Banker's algorithm works, and in the exam it can be asked for at least 10 marks or 15 marks. So we'll stop here, and in the next topic we'll see some new topic. Thank you.